Algebra 2 Honors, Lesson 3-2, Solving Systems Algebraically. Alright, here are the two objectives for the lesson. Alright, the first method that you're going to learn is the substitution method. Alright, now the most important thing in the substitution method is to pick the equation where one of the variables has a 1 in front of it. For example, if this is our problem, I know that I'm going to work with the bottom equation, right, because y has a 1 in front of it. Right? Y has the 1 in front of it. It doesn't matter if it's positive or negative. So the bottom equation is the one I'm going to begin with. Right? So we have 2x minus y is equal to 7. Fix this real quick. Alright, now you want to get the y by itself, so we're going to minus 2x on both sides. We get negative y is equal to negative 2x plus 7. Right? Y has to be positive, so we're going to multiply the whole thing by negative 1, so that'll give you positive y is equal to positive 2x minus 7. Basically the signs change for everything. Right? Now, the equation we haven't worked with, 4x plus 3y is equal to 4. Right? Now, since we know y is equal to this now, what we're going to do is we're going to substitute it right here. So instead of y, since y equals this, we're going to substitute it this in for y. That's why it's called the substitution method. Right? So we're going to get 4x plus 3 times 2x minus 7 is equal to 4. Then just work out the rest of the problem, distribute. We get positive 6x minus 21 is equal to 4. Combine like terms. 10x minus 21 is equal to 4. Add 21 on both sides. We get 10x is equal to 25. Divide both sides by 10. X is going to be equal to 5 over 2. Now that we know x, we still need to figure out y. Alright, don't forget to figure out the other letter. So all you have to do is take x now, plug it in either here or here, and then get y by itself. So let's say I plugged into the bottom. We have 2 times 5 over 2 minus y is equal to 7. Alright, this is nice because the 2's cancel. We're left with 5 minus y is equal to 7. Minus 5 here, minus 5 here. Negative y is equal to 2. Multiply both sides by negative 1. So y is equal to negative 2. So we know x is 5 over 2 and y is negative 2. Okay? So let's see one more example here. So down here we know we're going to work with the bottom equation, okay? Because both of these have a 1 in front of them. So which one do we get by itself? It doesn't make a difference as long as it has a 1 in front of it. So let's say we get x by itself this time. So we'd minus y here, minus y here. This will eliminate. So we're going to end up with x is equal to negative y minus 12. Now that we know what x is, we're going to take it and substitute it in the other equation right there. So we're going to get 2 times negative y minus 12 minus 3y is equal to 6. Distribute. We're going to get negative 2y minus 24 minus 3y is equal to 6. Combine like terms. This one are like terms. So we get negative 5y minus 24 is equal to 6. Add 24 on both sides. 5y negative is equal to 30. Divide both sides by 5. Negative. So y is going to be equal to negative 6. Alright, so y equals to negative 6. Now we're going to take this and plug it back in and figure out what x is. So we had x plus y is equal to negative 12. So we know y is negative 6, so let's plug it in. So x minus 6 is equal to negative 12. Add 6 on both sides. So x is going to be equal to negative 6. So our solution is negative 6 and negative 6. Okay? So that's the substitution method. Alright, the elimination method, alright, we're going to do exactly that. We're going to eliminate one of the variables. Alright, now sometimes we'll get a nice problem like this, where if we just combine, alright, if we just combine these two equations together, alright, one of the variables will immediately eliminate. Alright, that won't always be the case, but sometimes, alright, you'll get a nice problem like this. So if I add these two equations together, these eliminate, I'm left with 5x is equal to 10, divide both sides by 5, so x is equal to 2. Now that we know what x is, just plug it in to either one of these equations and solve for y. So let's say we plug it into the bottom, so we'll get 2 plus 2y is equal to 3 minus 2 on both sides. 2y is equal to 1, divide by 2. Y is equal to 1/2. So you know our solution is 2 and 1/2. Okay? Now in this problem right here, right, if we just combine, if we just add the two equations together, neither of these variables will eliminate. Right? So we've got to do something, to get one of the variables to eliminate. Right? First of all, since the 4's are already the same, I know that as long as one of them is negative, they will eliminate. Okay? So if this is positive 4x, if the bottom's negative 4, I know that it'll eliminate. So what I'm going to do is I'm going to multiply the whole bottom equation by negative 1, because what that does is it'll make it negative 4x minus 6y is equal to positive 2. Okay? Now the top equation still stays the same, we didn't do anything. So the top equation, 4x plus 9y is equal to 1. Now we're going to add these equations together, because the x's will eliminate now, which is what we want. Combine these, we're going to get 3y is equal to 3. Divide both sides by 3, so y is going to equal 1. Now you know what y equals. Just plug it into either one of these equations, right, and solve for x. So let's say I plug it in the top, so we get 4x plus 9 times 1 is equal to 1. Right, so that will give us 4x plus 9 is equal to 1 minus 9 on both sides. So 4x is going to equal negative 8. Divide both sides by 4. So x is going to equal negative 2. So our solution is negative 2 and positive 1. All right? Now this problem here, so we've got 3x plus 7y is equal to 15. And then we have 5x plus 2y is equal to negative 4. Now in order for either the x or the y to eliminate, we're going to need to make the numbers in front the same. First, you need to choose which variable to eliminate. It doesn't matter which one. Okay, you could have y eliminate or you could have x, right? But you have to choose one, right? So if I choose to have x eliminate, I have to know that, well, 3 and 5, okay, well, they have 15 in common. So since they have 15 in common, right, I'm going to multiply the top by 5. So this whole equation by 5. So that will give me 15x plus 35y is equal to 75. Now the bottom, if this is 15 on top, I know the bottom has to be negative 15. So what I'm going to do is I'm going to multiply the bottom by a negative 3, because that'll give me the negative 15x that I need. Alright, negative 3 times 2 gives you negative 6y. Alright, that is equal to 12. Now you want to combine the equations, because the x's will eliminate. This will give you 29y is going to equal 87. Divide both sides by 29. Alright, so y is going to equal 3. Alright, now that you know y, just plug it into one of these equations, alright, and solve for x. So let's say we plug it into the bottom one. So 5x, alright, we're plugging it in right here. 5x, alright, plus 2 times, we know what y is now, y is 3, is equal to negative 4, alright, so we get 5x plus 6 is equal to negative 4, minus 6 on both sides, 5x is equal to negative 10, divide both sides by 5, so x equals negative 2. So you know our solution is negative 2 and y is 3. Alright? So that's it. That's the elimination method.